Welcome to this TRL software presentation. I am Jim Binning and today I'm introducing you to TRANSYT 16, an international traffic modelling, signal optimization and design tool. Today I will be taking you through what's on this list here. What is TRANSYT? What is it used for? How it works? Modelling features, signal and optimization features, traffic flows, miscellaneous use cases, user interface reporting, time-saving tools, simulation model, and the summary. A lot to get through, so I won't be spending too much on each particular item. There will be a question and answer session later on, and also a very brief demonstration of some aspects of the product as well. So let's get started. So TRANSYT is both a design tool, an evaluation tool, and an optimization tool. The best description I can think of to describe the overall product is it's a macroscopic and simulation software package for designing, evaluating and modelling everything from a single isolated road junction to large mixed signal controlled and priority control traffic networks. So let's move on to a few of the things that it's used for to start with. What is TRANSYT used for? Its core use historically has been signal optimization in order to create fixed time plans, but in recent times it's been extended to be used for a number of other purposes along the way. One of these shown in the top right there is for design purposes, for example working out the best lane designation for a roundabout, which is quite a time-consuming job to do and can be done relatively easily with the tools built into TRANSYT these days. It can also model just as well as a modelling of a network. It can model single junction and evaluate and optimize the timings as well. It can be used to model corridors, and we'll talk about that later on as well. Used for the sort of bread and butter traffic impact assessment work that people do day to day whenever someone's building a development or whatever, or changing the road network in some way. Cable-less linking facility signal plans can be mimicked in TRANSYT. Scoop-based timings can be established. Vehicle actuation control maximum timings can be established as well. And more recently than all of these is it's been used to create config files within TRL for TRL's own brand new cloud-based UTC system, of course based on Scoot 7. So how does TRANSYT work? One slide to cover the whole of TRANSYT doesn't do it justice, but I'm just looking at the core signal optimization side here. So let's give it a go. A detailed traffic model calculates the performance index using traffic flows and turning proportions through a network structure of junctions and connection roads. So obviously you have to create that structure to start with. The performance index is an economic cost based on the delays and stops within the network, and TRANSYT optimizes the traffic signal timings across the network to minimize this cost. Added to this PI, as it's known, are other costs that allow you to favour parts of the network and to satisfy specific network requirements. So this is where when you're modelling corridors, for example, you'd be trying to favour a particular route through the network at the expense of the side roads. And I'll briefly mention how you do that later on. Of course, you can simply run existing timings in order to assess a network's performance. Here are a few of the screens just to show you what some parts of TRANSYT look like. These screens there, the timing diagram on the right and the stage sequence diagram in the middle, very interactive. You can change the stage sequence quite readily by dragging and dropping items. Timings, you can extend stage lengths or add in phase delays quite readily through the diagram itself. So very interactive user interface indeed. So let's move on. There's quite a variety of modelling scenarios and features that TRANSYT can model. Can't really list every single one, but I've listed a lot of the key ones here, so bear with me. Key thing here is the model, traffic model platoon dispersion effects, which of course are obviously quite pronounced on longer links in a network. Signalled full or partial and priority roundabouts can be modelled within one file, so you can do comparison between the different methods of control. You can also model short bays or flared approaches. Time varying traffic conditions can be accommodated. You're prepared to put in traffic flows for each of the different time periods. Effective upstream signals on downstream unsignaled junctions can be accommodated as well, so you get the added bonus of extra traffic across the giveaway line when it can see the upstream signals and what state they're at. And then you've got simulation of intermittent stages, and that's provided through the simulation model, which is new in Transit 16. We'll talk about that later on though. Other elements of the model that's relevant here is to mention the fact that in the modern transit, since about Transit 14 in fact, you now have a one-to-one relationship between real lanes on street and model lanes. You can still use the old link structure, which does have a few benefits, but generally most people prefer the new method. Choice of traffic model per traffic stream, that's important. That allows you to model the short bays and flares. It also allows you to evaluate blocking effects as well within the network selectively in the areas where it matters most. Stepwise traffic model has been established for a number of versions, and that allows you to deal with oversaturation modeling conditions where previously the turning proportion would be corrupted by that oversaturation, and that's no longer the case with this new model. TfL pedestrian walk in red behaviour model, the research behind that was carried out by TRL itself, and the model has been built into Transit. Another key element of Transit at the latest version is that traffic conflicts used to be limited to maybe 2 conflicts. You can have as many as you like, and that allows you crucially to set up the full set of traffic conflicts of different movements so that you can basically mimic the Arcady and Piccadilly conflicts that you set up, which is set up automatically for you in these products. Key signals capability. We have quite a lot of things here related specifically to do setting up traffic signals. You have RR67 SAT flow calculations built into the model. You automatically can generate stage based on the phases that you have in the conflicts. Automatic sequence generation as well, all the shortest sequences that are valid sequences and allow all phases to run. You've then got single, double, triple and quadruple cycling of stage sequences. Repeated greens can have up to 4 green periods rather than just say double cycling. You can just run one stage extra twice within the sequence. You can also lock stages on one controller to another one to mimic a CLF situation. And then you've got various user interface improvements like timing wheels, which is an in-diagram method of editing the stage timings. An example shown there as a sort of pizza-shaped wheel with the cycle time in the middle and the stages around that, showing stage 1, 2 and 3 there. Then finally you've got phase optimization and simulation mode, and they're covered on later slides, so I'll leave it till then. So moving on to signal optimization, Transit is used to optimize signal timings or the retiming of single isolated signal junctions or partially signaled junctions, and similarly for roundabouts can be signaled or partially signaled. Obviously for modelling far larger networks of town or city centres, it can mimic CLF linked signals by locking stages from one controller to another, and it can be used for prioritising of specific traffic types such as buses or trams, which dates back to the very earliest days of Transit. Additionally, you have the choice of optimizers within the model. You have a traditional hill climbing method, which is very fast and efficient method of giving you good timings. You've got shotgun hill climb that deal with, if you're prepared to spend a wee bit longer time, you can actually get it to improve the results on average if you're prepared to use that option. And then you have simulated annealing, and that tends to have a benefit when you're, say, using the stage locking, which can make the hill climb optimizer slightly less efficient. But again, you have to wait longer for that model to finish using that option. And then finally, a new option in Transit 16 is the ability to very quickly run all sequences that you have available in the file at the time in order to find out the best one, so you can change the stage you're ordering around for every different combination that you have there. Okay. Moving on, let's look at the optimization of phases now in Transit. What we have here is optimization is mostly stage-based in transit, but individual junction phase-based optimization is available too. No, it's not for the whole network, it's for each individual junction. This offers a quick way to find out how a junction will perform, and you need very little information. You need to specify obviously your network, scale the network diagram, and from that Transit will work out conflicts and intergreens automatically for you using UK DFT values of intergreen. Automatically define a library of possible stages, define a collection of stage sequences, shortest sequences first, and then optimize the signal timings to minimize delay, including adding any phase delays if it improves performance. All of that is done more or less by one click of the button. The top one, conflicts, is done by one button, and the rest is by a second button. So 2 buttons technically. So let's look now at the flow allocation to network. This is a particularly important aspect of the product because obviously without flows, nothing works. You have a very simplified allocation of flows using ODE matrices for each individual junction. You have a vehicle path generation that's done for you, so you don't have to worry about the path generation underneath the skin of the product. You allocate the flows to the paths automatically balanced by degree of saturation, or you have full control to manually set them based by percentage of flow or fixed flow or whatever you require, and you can mark regular paths as being band paths if you want as well, in order to make sure that you have the flows allocated exactly the way you want. Finally, for local area, so this is complex junctions where you have a genuine choice of route through the junction, maybe like a magic roundabout, or for a far wider area, you can use a user equilibrium assignment model to allocate traffic. And that assignment model actually allocates the traffic to the local matrices, and then the local matrices deal with it from that point onwards. It's a method that works really well in practice. Additionally, with traffic flows, you have multiple traffic types, each associated with PCU factors. Buses, trams, and normal traffic is normally the 3 that you use. They're in a separate underlying link structure, but share the same capacity through the network. You also have a choice of input and output units, vehicles or PCUs, and you have time varying flows, which I think was mentioned earlier, but here's an example of one of the graphs from Transit showing you results across different time frames on here. Moving on to a particular use case is looking at impact assessments, and there's various facilities built into Transit 16 to facilitate that. So this is for evaluating the performance of, say, existing base case networks or junctions, and then the impact of proposed developments. Because of that, you clearly want to store multiple sets of data and results within the one file. So you can do this in Transit very easily, so you can represent different traffic flow scenarios and different signal plans for multiple peak periods. So typically you might be modelling an AM and a PM peak period for the current year, and then for a future year, and also for the base case for base flows plus your development flows. So you've got the ability here to set up composite demand sets, so you can have the base flows entered through your OD matrices. You then add in your development flows in a separate matrix, and then you can set up a demand set, which is a combination of the two, and any other development you might want in as different options. So you can have as many of these as you like. The system allows you sharing of or the separation of data between the sets. So if you do want data spread across sets and shared across them, you can do that for certain data items, and then for other ones you can choose to have them separate. Some elements are mandatory to be separate, so the signals are always different between each analysis set, and there's probably similar rules for the demand set as well. You can associate and run multiple demand sets per signal plan. This is something that wasn't possible in Transit until the latest version, Transit 16. So you can have analysis set 1 running, say, demand set 1 and demand set 2. And here you've got, I think in this example here, analysis set is running D3 and D4, as shown in the grid on the far right there. And this shows you some results very easily and nicely laid out, showing you the results for 4 different sets of results here for your AM and PM, for 2 different years in this particular example here. More on impact assessments. Another new feature in Transit 16 is what you can do is you can specify specific demand sets to run with the analysis set as shown here, D1 and D2 for AM and D3 and D4 for PM. But additional to that, you can also specify that you're going to optimize based on the specific demand set. So that allows you to say, for example, that you can run the model, optimize it based on demand set 1, and then you can run demand set 2 automatically, but it will be using the timings from the optimized set. So there'll be evaluation runs using existing timings. So that way you can set it up, for example, to do some robustness checking. So D1 could be your main run of the program that you're interested in to optimize the timings, and then the second one could be saying what happens with these timings if you suddenly get a peak in traffic demand on a particular day, say they're 10% higher than normal. You can set up DT2 to represent that scenario and run that within the file quite easily now. Okay, and then of course you've got to use the equilibrium assignment model there, which I've already mentioned, in order to allow you to distribute flows across a wider network if you need to. Corridor modelling. I mentioned this earlier, and Transit can produce optimized timing that facilitate the progress of traffic along corridors within multi-directional green waves. There are several Transit features facilitate the evaluation and optimization of corridors. A lot of them are just part of the core model and is there anyway, but we've added in a couple of things that do help specifically for this scenario. One is to apply a combination of weighting factors, so you can apply delay weighting to encourage the signal optimizer to reduce the delays to travel for traffic travelling along the corridor itself at the expense of the side roads, of course, and also apply degree of saturation limits can be sometimes an easier way of doing a similar thing, and there you associate penalty costs again to produce timings that favour the through movement along the corridor. The key thing about the optimization is it's always trying to minimize the cost, and if you throw in extra costs because of a degree of saturation limit having been exceeded, it will try and steer itself away from that as a solution because it's too costly compared to some other solution. Transit, of course, has been extended over the years and is now a very useful tool for design purposes. And one of the obvious things to demonstrate that by is looking at the new flow overlay built into the network diagram facility, because that assists greatly in designing your junctions. It's there to significantly speed up the time-consuming process of working out lane designations, negating the need to use external lane flow design tools, which previously people might have used. A graphical lane flow overlays helps you ensure optimum junction layout, and to facilitate that, for each lane you get a flow volume information per lane, and it's color coded by source to destination. You can filter it out for particular movements, so there's various options there that I won't have time to go through them all, but allows you to model multiple scenarios of peak traffic flows as well, using the multiple analysis and demand set, so you can try out different strategies within the one file, which obviously makes life easier. And then you've got your user equilibrium assignment model as well. Just to zoom in on that diagram, just to make it a bit clearer, you can now see that on the approach 1 there, you've got traffic leaving, which is the blue. So this is showing you the color coding based on destination. So you've got here bulk of traffic, looking as if the bulk of traffic is a through movement there, which is green, 250 vehicles in each lane. And you can see how, based on the lane designations, you've got something like 281 in the middle lane and 219 in the green on the right hand lane. And very easy using this system to spot where you've got lane starvation going on, or you've messed up the connections within the model itself. So it's a very useful way of actually checking to see that you've got everything set up the way you want to in your file, as well as obviously allowing you to work out the best lane designations for your, in this case, a signalised roundabout. Transit 16 for a number of versions has now had the ability to model priority intersections. What we've done is taken effectively, if you've got a license for Arcady or Picady on your PC, you have access to the same models as arcane-picity in effect in terms of working out intercept and slope coefficients, which are then put into the transit model. What the priority intersection tool is effectively a layer above the main transit network, where you allows you to specify and retain the standard arcane-picity geometric data. It will then work out all the conflicts automatically for you, and all you need to do is then attach that data to the network, and then we'll copy it across into the intercept and slope and intercept equivalent values in transit in order to run the model there. So this method allows you to actually, you can remove the priority objects and still run the model. Once you've allocated it to a network, then they're just a holding place for the extra data they require in effect. So removing them won't change the results. I've got a few slides here just looking at a few of the key user interface features that might be of interest to existing users of transit as much as for new ones. You have a great grid system here, so for whatever different methods that you can use for data entry, of which there's several different ways of doing that. One of the quickest one is to use the grid format. One key thing about this is it's customizable, so you can add and remove items to it. You can add results in among the data. You can save these, put them into reports, etc. And key here is the thing demonstrated that you can select multiple items here, and you can say edit all and edit them all simultaneously. So if you want to switch the option on for across the whole network, you can use this grid to select everything in a particular column and set them to one item. It applies to data items, checkboxes, drop downs, anything you want on there you can do. Of course, in addition to the just the grid, you have a feature-rich editable network diagram, which is I'll rely on using the demonstration later on to look at some aspects of that rather than trying to show you slide after slide of its capability. You also have a library system for storing template files, and we supply a number of useful building block files to allow you to set up junctions or parts of networks very easily indeed. And of course you can save your own templates as you go and get more familiar with the product. Within the network diagram, you have the choice of 2D and 3D views, and you have animations there of either of moving traffic simulated in here, or various other things showing you just the volume of traffic, for example, in a static diagram. All the windows, by the way, including this one, can be taken out of the main product window and put on another screen. So we do recommend that having 2 monitors is brilliant. 3 is even better, but I would highly recommend using more than 1 monitor, because there is a lot of content in transit, and the more real estate on the screen you have, the better you'll feel using the product. The savable screen layouts help you as well, because they accommodate the dual monitors as well, so that you can save certain views for particular purposes to speed up when you come back to the file later on, having closed the product down. Reporting, mustn't forget the reporting side. You have a customizable graphical HTML report. All the output is in one particular order, so you don't ever lose where stuff is, but you can add and remove stuff as you require in it. So you can have a very succinct, short report, or you can have more or less all the input data, all the output data in a very long report indeed, if you want that. You have the customizable tables that I mentioned earlier that are saved through the data grid system. These can appear in the report as you require. You can also have the option of converting the HTML report into Word or into fully paginated PDF. You can embed traffic and cycle flow profile graphs into the report as well. And finally, you've got great facility for comparing data within a file, either internally between different data sets. So if you want to make sure that 2 data sets have exactly the same differences that you expect to see between them, you can do that within the one file, or you can compare 2 completely separate files to see how they compare with each other. There's a lot of additional reporting facilities here. You can ask optionally to have a relative controller offset value reported relative to a locked master controller offset. You've got location to location journey times within each ODA matrix, which can be very useful. And then you've got separate vehicle and pedestrian summary results shown in the outputs as well. Some of the diagrams are shown there. You've got the XY analyzer graphs shown on the right hand side there. more or less you can plot any X parameter against a Y parameter, so it gives you really great flexibility, and you can multiple graphs plotted on one diagram, so it can be used for quite a lot of different purposes. And then on the bottom left there you've got the traditional cycle flow profile graphs and a more modern time distance diagram showing the traffic flowing from one upstream set of stop lines sources down to the final stop line below. Cycle flow profiles, of course, are great for network validation and interpretation. Once you get to learn to understand what they represent, they can be very, very useful indeed to check to see whether you've got a good model on your hands. Moving on, we have a number of time-saving features. Can't cover absolutely everything in the product, so I just picked out a few that are particularly useful. We have a built-in integrity and conflict calculator now. So once you've got a network scale network diagram in front of you and you specify the phases of what they're controlling, you just press one button and it will populate the integrity matrix with all your conflicts and also integrins based on DFT, UK DFT values. A new facility built into TRANSYT 16 is a recognition of the fact that for a particularly large network, or probably even for smaller networks like signals roundabouts, you have a lot of artifacts on the screen in terms of traffic streams and locations and controllers, etc. Here you can automatically name them afterwards, so you can throw the network together, not worrying about the names at all, and then you can go into the screen and automatically name the controllers based on where they're placed on the screen, and then you can start naming the other item based on either the controllers or the arm names or the traffic stream names, etc. There's quite a lot of options in there. You can specify the movements, so that allows you for the traffic stream names to populate that with L, R and T for the left, right and through. It's particularly useful to identify which traffic streams are providing which movements within your network. And you can also specify things based on the 8-point compass direction as well if you want as an alternative. Okay, there's various other auto calculations going on in the model as well to minimize the amount of data entry. So traffic stream lengths are automatically calculated from a network diagram as long as it's a scaled diagram, and turning radii for RR67 calculations, etc., or proportional turning vehicles is all calculated for you if you want it to do that. Everywhere that happens, you can always override it. We don't expect that it'll cover every possible scenario, so there's always a way out of that, so you can always put in your own values if you require. Another time-saving feature is the batch running facility, so you can choose, select all the files you want in a particular folder, then choose evaluation run or optimize runs, whichever you prefer, and it'll run all the analysis sets and demand sets within these files based on the ones that are prescribed in the files as being wanting to be run in the first place. So you set them up in the size of the file first. Then you choose the runs. You have a choice of results shown in the batch run summary screen on here. Obviously you can open up each individual file later on to look at the full raft of outputs. And on here, here's an example showing you the fact it's running analysis set, the demand set, the performance index, total network delay, highest degree of saturation, etc. on there. And if you need a command line interface, talk to us. We have developed one, but it's not commercially available at the moment, so do come and speak to us if you want to be able to run the underlying models, but without going through the user interface. Here's an interesting slide. For those who are familiar with Junction 9, if you also happen to be wanting to use TRANSYT as well, then it's a lot easier to learn TRANSYT than you might think, because we've deliberately designed to share common UI elements within Junction 9 with TRANSYT and vice versa. They tend to leapfrog each other in terms of elements, so one will improve and then the other one will copy some of the improvements back into the other product. So the data outline editor is in both products. Multiple analysis and demand sets is more or less the same. There's a few differences, but since TRANSYT 16 came out, they're very similar indeed in how they operate and its capabilities. You have an origin destination method for entering traffic flows, a dynamic link to import demand data from itself now common across the two. You've got a network diagram, is very similar in some respects. Some results screen is almost identical. HTML report is very similar as well. Analyzer screen is, you can't tell the difference really between them. Very small differences. Signal screens and data is also very similar between the Oscary 9 module in Junctions 9 compared to Transit as well. So familiarity with one of the products will help you a lot with the other one. Here's a picture of the two, so we can see how similar various screens are. You've got the diagram in the top right there, you've got the intergreen matrix just below it. Right in the middle at the bottom you've got the timing diagram, summary results in the bottom left there, data editor, and then the simulation screen there, which allows you to set that off running. Is again has very similar elements to it. Transit, of course, benefits from interacting with other third-party products. People use a number of other products in order to capture data, for example, like traffic flows. So we made sure that you can copy and paste data in and out of the product quite reasonably and easily with a clipboard or via the data grids. So anywhere you see a grid, you can normally copy and paste out and back into the product. We've also had a number of importers from other products built over the years, and then more recently we've built in the Junctions 9 facility to build a dynamic link to Excel is now being accommodated in Transit as well, because we realise a considerable amount of people are storing a considerable percentage of their traffic flows at some point in Excel, and being able to import flows from there. And if we can use their layout, so it's designed so that the layout that you have in your Excel can be retained. You don't have to basically design it to fit in with Transit. Transit, to a large extent, will be to accommodate quite a lot of different varieties of layout within your spreadsheet for you. An example shown there where you've got a nice sort of someone's gone to the trouble of creating nice sort of approaches with the different movements on it, and that can be accommodated in the importer facility. And once you've set it up once, as long as you use the same format in Excel later on, you can just keep using that same template. And finally, you can generate a entire transit file from within Junctions 9 now. So if you do work with Junctions 9 and you're, say, modelling just a single signal junction and you'll optimize it in there, and then you suddenly realize you want to attach it to a wider network, you can then export to a transit file, and then you can merge that into your transit network more or less seamlessly. Most of the data is copied across now. Moving on, we'll move on now to the lane simulation. A very brief history of that for you. The lane simulation mode first developed for Junction 8 and it was extended in Junction 9 and proved very popular. So we extended it in Transit 16 to take account of cruise time through the network, because Transit obviously is modelling more than one junction normally, and in junctions normally one or very closely spaced junctions within a small network. We've added in the option for stages to come in randomly or every X cycle, which allows better modelling of demand-dependent scenarios. And of course, there are going to be further, it's early days with this simulation model in some respects, so further enhancements are inevitable, both in junctions, so that will be Junctions 10 and also in the future Transit as well. So let's look at simulation and what it does. Evaluation runs in simulation mode allows you to evaluate the performance of your network throughout the model time period and can display graphical animations of the estimated position of individual vehicles. And here's an illustration of a signal roundabout with colour-coded delay per simulated vehicle. So the darker the red, the longer the vehicle has been waiting in the network. The blue blobs on there are actually the moving vehicles as opposed to the ones that are somewhere in a queue. It allows you to model crucially uncoordinated traffic signals. Transit assumes a cyclical nature of signals, so it's not really geared up to modelling uncoordinated traffic signals, so the simulation model gets around this problem. It can deal with lane starvation inherently within the model. Intermittent stages can be accommodated as well, as I just mentioned in the previous slide. Modelling of complex signal flare approaches can be modelled very well, and blocking back effects as well. The original model had a blocking back effects model, but this is a more natural way of modelling it throughout the whole network. It doesn't optimise, but you obviously can use it for evaluation purposes. You can optimise using the other model, and crucially you can switch back and forth relatively easily between the two. You don't have to start specifying more data just because you've gone back and then come back again. You can do that quite readily. Various features. Results are collated from multiple trial seed evaluation runs. They're surprisingly quick because it's a simple model. We're not trying to recreate some large, expensive, cumbersome, hard to understand microscopic model. This is simple. It's based on TRANSYT in the same way Junctions one is based on the core Junctions model. The results are recorded for individual traffic movements. You can use individual vehicle animation to check behaviour, calculates and visualize cube percentiles, and they're always produced. They're not situations like in Junctions where sometimes they're not generated because of the circumstances of the traffic flows. And then finally you've got the signals log. This is a very visual way of representing throughout the model time period. You can see the red and green times shown there along the top for the different phases shown on here, and then it marks out the stages on there with the timings on it as well. The blue and green at the bottom there, in fact, is a hidden option which we haven't officially released, but is in the product. If people did accidentally could find that if they knew which keystrokes to use. But we've used this mainly internally for checking that the model is doing what we expect it to do in terms of capacities and queue lengths, etc. throughout the model period. And we might expose that in a later version to customers as we see fit. And of course, even with larger networks, each trial run is surprisingly quick to run. So even for a particularly large network, this is quite a decent sized one here, so that's why I'm showing it. It's anonymized, so someone might recognize where it is, but it is in the United States. But and for commercial reasons, I'll keep that quiet where it is. Getting towards the end of the presentation now, a few things just to mention about international use. It's suitable for driving the right and driving the left. There is some choice of units, so you can choose the units cost from pounds to dollars or whatever you want, or input and data and results can be changed for various units as well. You've also got a setup wizard to choose between UK, US and Chilean settings. And you might think that's an odd selection there, but it'll become clear why that's on there. One thing, we have the US terminology option built into the product at the moment. We also have an alternative Chilean platoon dispersion model built specifically for that market that's accessible but generally used only by them. And then we have SCAT, split timings, and dump file flow importer available as well. So SCATs of course uses their stages defined on the stage length, including the following interstage, and it's presented normally as a percentage of the overall cycle time. So that's available and can be shown in, for example, the timing diagram has an option to show that on us instead of the traditional transit stage definition, which is obviously different. And then the dump file flow importer is something new built into TRANSYT 16, so a relatively recent addition there. And then finally, we actually have again another hidden thing in TRANSYT, which is a built-in language translation assistant. So we can expose potentially for anyone who wants to translate in the product and prepared to do some of the legwork themselves. We can actually provide a version which allows you to have a flat list of basically all the phrases that appear in the user interface, and then adjacent to that there's boxes where you can fill in your translation. That comes straight back to a server at TRL, and we can incorporate that into a specific hardwired language translation of that product. So it's a very good system for setting up languages. We have done some translations in previous versions, but we don't have one for TRANSYT 16 at the moment. But do come and speak to us if you're interested in translation into another language. Summary, last slide, you'd be glad to know. TRANSYT complements Junctions 9 by modelling more complex single-signalled or partially signalled or fully signalled junctions and far bigger networks. Optimises timings for these complete networks. You can share the data, share the same data across multiple junction types, so you can model, say, a fully signal roundabout versus a partially signal one, and get the results for both of these within the one file, which makes it really easy to work out what the best option is. And then there's a quick learning curve, as I mentioned just recently, thanks to sharing many aspects between Junction 9 user interface. So you use one product, you're investing in the other one as well simultaneously. Demand-dependent situations can be modelled using intermittent intermittent stages using the innovation simulation model that was recently built into TRANSYT 16. I'll finish off with some information about subscriptions, support and product updates. The product is accessed through paying for a subscription, and as part of that package you will get support. Access to the support can be done through a telephone number, email or web support. Additionally, as part of the package, you will have free updates to the latest version of the software, no matter what version and how big the changes since the last version were. You will also get access to that whenever you like via the TRL software portal, which is part of the package as well. And additionally, in the TRL software portal, you'll find that there's a cloud-based collaborative space that allows you to upload files, save them and access them through the product itself, and share them with either your colleagues or with external clients if you so wish to do so. I think these additional features will be particularly welcome, especially the need to collaborate on projects. Thank you very much.